Hi, we are doing the presentation portion of the written exam for Module 2. First, we're going to start off with the Venn diagrams. What you will notice is I color code everything, so that should help you when you're helping your student to understand and follow exactly what I was doing in the process of working each problem. So a couple of things to know about Venn diagrams. Do not get overwhelmed. We can get through this together. This, what looks like a U, is a union, and that means and. This upside down looking U is the intersection of sets, and that's where everything that two things have in common. This line above a capital letter, which is a set, means complement, and that means there are no elements of that set included in whatever the problem is saying. So here I'm going to explain the first one pretty good, and then you should be able to follow my steps in the additional problems. This means universe. It is not to be confused with the union symbol. So in our universe, which you will see in our diagram, is this large rectangle, is A, B, C, D, E, F, G, H. Then we have it broken down to set A, set B, set C. Everything I have, if it's included in A, it's going to be in the blue circle. If it's in B, it's going to be in the pink circle. And if it's C, it's going to be in the orange circle. The easiest way I have found to do this is start in our universe, this set of our universe, and look, there's A. Then look in set A. Is A in there? No. Is A in set B? No. Is A in set D? No. So in this case, we know A is just in the universe. We will look at, let's pick one that they share. Okay, D. D is in A, and D is in B, and D is in C. So what you're going to do is look to see where there's a space that a portion of each A, B, and C circle combines and shares a circular area. So you can see right here, D is in A, B, and C. And you'll notice in here, H is also there. But that's how that's broken down. When we read this, in A, you're going to see B union C, which means all elements in both A and C. So under it, you're going to see where I shaded in what you're going to include. And in this case, it's all of B and all of C. And I did the same thing for each of the problems after that. You'll see how it's broken down, and I've shaded, like in B, it's this little bitty sliver, and that's green. And I tried to, when it's a small area, I tried to draw an arrow to show you what we're looking at. And that will get us through problem 1, A through G. Then we get down to problem 2. Problem 2 is similar to A. We're using the same union, intersection of set, and complement. Here, we know that there's shape, size, and color, and you have a bunch of letters. Don't worry, we're going to break this down. So what we see in here, we have red and blue. We have circles, triangles, hexagons. Then we have small, and we have large. So we notice on the side, we kind of made a key. We have shapes, and I underlined C for circle, T for triangle, H for hexagon, and you can see how I've followed through with the different labels. Then we can look at A. It says shapes found in the set L, intersection of sets H. Now this intersection means we only want shapes that share L with H. So that's L is large, H is hexagon, so we're only looking for large hexagons. And that continues, and it's written down so you can understand that. Then we get to problem 3. Problem 3 is, do not be overwhelmed by this wording. It's Indo-Arabic equivalent. This is what you need to know as a parent or fellow teacher. It's pretty much what we use in modern times. For us, our standard, it's what we base our decimal system on, so don't panic. You will see A through D, there is a table with your key and this will help you in figuring out what we're looking for, what the symbol means. So we have the symbol with what our equivalent is. So that's where you follow. And I have it broken down. You can see on A, we have, if you follow up here, that same symbol is a pointing finger. One of them is equal to 10,000. So we have 3, so we know there's 3 10,000s, which is 3 times 10,000, which is going to give you 30,000. And you're going to follow through with that. This symbol is a yoke, and we know a yoke is equal to 10. So we have 5 of them. 5 times 10 is 50. And then our last symbol is this staff, which is equal to 1, and we have 4 of them. So that's 4 ones. 4 times 1 is 4. So when we add all 3 together, we have 30,054. And I put that in the box. Anytime you see something boxed in, that is my final answer in that rectangle. Okay, and that follows through with each problem. In our Roman numeral, remember that if a smaller Roman numeral or is in front of a larger Roman numeral, that means to subtract. So let's look at this one a little bit. We know M is equal to 1,000, but then we have C, which is equal to 100, in front of M again, right here. So what we're going to do is that means subtract. So we have 1,000 minus 100 equals 900. So we have to remember that when we're figuring out this problem. In D, the key here is we start at the bottom. Theirs is vertical, which is up and down. So you're going to start at the bottom first and work your way up. So when we look at that, this first symbol is equal to 17. 17 times 1 is 17, and you work yourself up. And then after you work it up, you are going to add it all together to get your final answer. Lattice multiplication. This has a lot of steps, but it's really fun, and I believe your students are going to enjoy it once we help them figure it out, but it's really fun. We have to remember that the first number in our equation goes across the top. The second number we're going to write going down on the right side. So here we have 28 times 32. On the first problem, I broke it down step by step so that you can follow it and get a good grasp of what's going on. So on the first step, we have 28 going across the top and 32 going down the right side. Then in step 2, it says create a rectangular array of boxes to fit the problem, which means there should be the same number of inner squares or rectangles as there are numbers in this problem. So there's 1, 2, 3, 4. So we should have 4 squares inside. Now, That step 2 is in black. Step 3 is yellow. That's when I added the diagonals, because inside each of these rectangles, we need 2 triangular spaces. So that's what we did in step 3. Step 4, we're going to multiply, and this is how this is going to happen. Your product always needs 2 digits. So if we know here 2 times 3 is 6, well, that's just one number. Put a 0 in front of it, because a 0 in front of the number does not change that number. We could have 10 zeros in front of 6. That's still the same as having 6. So in this case, you're always going to have 2 digits, and the 0 would come in front of the 6. So 2 times 3 is 0, 6. The first number goes in the top area. The second number goes in the bottom. 8 times 3 is 24. So 2 goes at top, 4 goes in the bottom. Then we're going to come to the first number again, and we have to multiply it times the second number over here, and that matches up here in this rectangle. 2 times 2 is 4, 0, 4. 8 times 2 is 16, 1, 6. So that's step 4. Then we go down to step 5. In step 5, we're going to add all the numbers that are in that diagonal area. And once again, I color-coded this. So in this first shaded diagonal, and you always start at the very bottom right corner. And then we're going to work our diagonal going up. So first we have 6. So we're going to put 6 under here. Then we're going to add everything in this blue shaded area, and that's 4 plus 1 plus 4, and that gives us 9. So we're going to write 9 under this diagonal. Then we're going to go to the green shaded area, and we have 2 plus 6 plus 0. That gives us 8. And then we're going to add that last diagonal in the pink area, and we have 0, which is 0. Then in step 6, we're going to start in this top left. We're going to go down, and then you're going to go across to the right. So what we have is 0, 8, 9, 6. We don't write in our answers, we don't include that 0 in front. We take it out. So that's why you see a red line through our 0. That's what we did. So 28 times 32 is equal to 896. And I have worked each problem after that in the same way. You will see the diagonals in shaded in different colors, so you can follow this process. Remember, this first number goes across the top. The second number goes down on the right side. We're going to do our multiplication to figure out these inner numbers, and then we add in the diagonals. And that will get us to problem 3. No. Oh no, we're on 5. Yay! Okay, we're almost there. Number 5, we're rounding to the leftmost digit. And I'm probably doing this backwards since you're looking at it. So we're going to look at the number farthest to the left. And I understand that sometimes students get confused with this. So we're rounding all the way to the left. So in this problem, we're looking at 883. We want to round 9. Well, to know if we round up or down, or if we round up or the number stays the same, and for the first number, we have to look at the number immediately behind it. So in this case, we have 8. We look right behind the 8, and it's another 8. If it's 5 or greater, we're going to round up. So in this case, our 883 rounds up to 900. Then we're going to add, and behind it is 465. The first number in that the leftmost number, the leftmost digit in that number is 4. So we look behind it, and it says 6. So 6 is greater than 5, so we're going to round up. So that makes 465 round up to 500. On the bottom, we have 134 as our divisor. 1 is the first number, the first digit. It's our leftmost digit. So we look behind it. It is 3. So that changes. It rounds to 100. And that's how we go from there. And then we're wanting to know what the estimate is, what our exact number is, and we want to see the difference so students can get a feel of what's going on when we round numbers. In problem 6, this is operations in the relative base. And this is pretty simple. It looks like a lot, but it's good. They're going to get it. So base 5, what that means is we're looking, think groups of 5. Anytime there are 5 or more, we're going to group it as 1 and move it up to the next level. So think we have columns, the ones. So we're thinking ones place, tens place, hundreds place, thousands place. Our basic decimal system. In this number, 432, because we have 432 plus 133, we have 400. So that's going to be 4 in the hundreds column. 3 for 30. So that's 3 in the tens. And you see 3 dots there. And 2 in the ones place. So 2 in the ones column. For 133, we're following the same idea, same pattern. 1 in the hundreds place. 3 in the tens place, 3 in the ones place. So now imagine this without the circles. So at this step, you should just have dots. Well, what you're going to see on your paper are 5 dots in the ones place. We're going to group those 5 dots together because what we know is in this base 5, if we have a group of 5 or more, we need to group 5 together and move it as 1 unit to the higher level. Since we have 5 ones, we're going to group that together, move it as 1 unit to the tens column. So then, and you see I have 1 blue unit so that you can follow what I'm doing. It's grouped in blue, move to the next column. We originally had 6 dots. And then we added 1 more in blue. So now we have 7. 7 is greater than 5. You're going to make 1 unit by grouping 5 together and moving that 1 unit, because that group of 5 is 1 unit, going to the hundreds column. And that's there in green. In this, now in the hundreds column, we had 4 plus 1 plus 1 more, and that's going to give us 6. Once again, we only want, anytime we have 5 or more, we need to group that as 1 unit. We need to group the 5 as 1 unit. So here I circled 5 of the dots in orange. That becomes 1, that 1 set of 5 becomes 1 unit, and I'm moving it to the thousands column. So when we add this together, we have 1 in the thousands. Now this group moved, so I can't count that. But I do have this 1 green dot, that's 1 unit. And then in the tens, remember I grouped this as 1 unit, so I can't count that. But I do have 1, 2 remaining in the tens column, so that's 2. And then in the ones column, I have this group in the blue circle. We moved that, so we can't add that. So I have 0 in the ones column. And we're going to do, when you go to B, B is base 6, so it's the same idea. except this time instead of 5, if it has 6, we're going to group it in a set of 6, and then that will make a new unit. And you can see I worked that one the same way I did A. The 6 is the only difference. Then when we get to the C, we have C and D are both base 5, except this time we're subtracting. So just think a little in reverse. We started out the same way. You know, if it's 414, you're going to have 4 hundreds, so 4 dots in the hundreds column, 1 dot in the tens column, and 4 dots in the ones column. And those are all, you're going to see that's done in pencil, so you can see it's a different color. Then on the bottom row, we have 43, so it's 4 in the tens, 3 in the ones. When you start subtracting, anytime we have to borrow from the higher unit, you know, to bring it to the higher unit, we took a group of, in this case, 5, and we made 1 unit for the higher column. Well, think reverse. If we're taking this 1 unit and bringing it down to the lower column, then we have a group of 5. So we're just doing the opposite of what we did in previous problems. So in this one, you'll see in the tens column, there's only 1 dot in the top row. That's where you should be when you're working your problem. And I have 4 in the bottom row. Well, we can't take 4 out of 1, so we have to borrow some from the hundreds column. So we're going to take that 1 unit from the hundreds, bring it down to the tens. Well, that 1 unit is a group of 5. So we're going to have 5 dots, and you see 5 colored dots there. And then what you'll notice is as I cross them out, I link the 2 that are canceling. So that's what's going on. If I'm subtracting 1 here, well, I'm subtracting it from here, so I'm canceling them out. And it's giving whatever doesn't have a line through it, whatever is not canceled, that's what our answer is at the bottom. So that's 1. Here we have 2 remaining in the tens, so that's 2. Here we have 3. We do not include what we moved down to the lower column. And that's also how we did 6D. Good luck with this. Have fun. Math is wonderful. It's an accomplishment when you're done. Have a great day.